Assalamualaikum and very good morning. I am NUR ATHIRAH binti Nik Muhammad Sabri. My metric number is 1171506. I had been done my internship for 18 weeks at Malaysian Palm Oil Board Bangi and supervised by Dr. Maznah binti Zainul. Malaysian Palm Oil Board is a premier agency under the Ministry of Plantation Industries and Commodities. It is established on 1st of May 2000 through a merger of the Palm Oil Research Institute of Malaysia, PORIM, and the Palm Oil Registration and Licensing Authority, PORLA. MPOB also provide effective service, which the main focus is on research and development. I had been assigned under Product Development and Advisory Service, which is called PEDAS. PEDAS division had 4 units, which are Analytical and Quality Development Unit, Nutrition Unit, Food and Feed Technology Unit, and Technical Advisory Service. MPOB assigned me under Analytical and Quality Development Unit. Dr. Maznah had assigned me a project regarding development of analytical method for determination multi-residue pesticide in mesocarp and crude palm kernel oil (CPKO) by using pressurized liquid extraction (PLE) and quick, easy, cheap, effective, rugged and safe methods. Why we need to do this method? This is because in regard food safety issue, raw material and final palm products should be free from any contaminant including pesticide. However, there are no analytical method for mesocarp. The objective for this project are to develop the analytical method for determination of multi-residue pesticide in mesocarp and CPKO by using PLE and catches method. To validate the analytical method for determination of multi-residue pesticide in mesocarp and CPKO by using PLE and catches method. For PLE method, the mesocarp sample need to spike with working meat standard solution, load the 5 extraction cells that fill with spike sample to PLE, and then run PLE with preferred method, which are altering the condition. The extraction was evaporated under a rotary evaporator to near dryness at 82 degrees Celsius. The compounds were collected by adding 5 ml of acetonitrile and then evaporate the extract under a nitrogen evaporator. Next, the residue was reconstituted in 1 ml of acetonitrile for injection into GC analysis. 1 ml of the extract was transferred to a DSPE tube containing 50 mg of fluorosil. The tubes were shaked for 1 minute and centrifuged at 3000 rpm for 5 minutes. Finally, 1 ml extract solution from each tube was filtered using nylon membrane filters and transferred into GC analysis. For catches method, CPKO sample firstly need to spike with working standard meat solution. Next, the mixture was added with 10 ml of acetonitrile. The tube was shaken for 1 minute using vortex mixture at full speed, and then add 4 grams of magnesium sulfate and 1 gram of sodium chloride. Then the tube was shaken for 1 minute using vortex mixer at full speed and undergo centrifugation at 4000 rpm for 10 minutes. Next, 1 ml of supernatant was transferred to clean up procedure, which is DSPE, and 1 ml of the extract was transferred to a DSPE tube containing 150 mg magnesium sulfate, 50 mg PSA and 50 mg C-actin. The tube was shaken for 1 minute before centrifuge at 3000 rpm for 5 minutes. Finally, 1 ml extract from the tube was filtered using nylon membrane filter and transferred into GC vial and transferred to GC analysis. For optimization of catches method, solvent selection, vortex time selection, the SPE cleanup selection. Meanwhile, for PLE optimization method, we select the solvent and the SPE cleanup selection. This is the retention time of working meet standard solution by using GC micro ECD for PLE method. Tetraconazole at 14 minutes, penconazole at 15 minutes, endosulfan at 16 minutes,
propiconazole at 20:061 and 22:89 minutes, epoxiconazole at 21st minute, and deltamethrin at 30:461 and 38:53 minutes. Propiconazole and deltamethrin had two peaks as the compounds had two isomers.
This is also the retention time of working meet standard solution by using GC micro ECD. However, this is for catches method. Tetraconazole at 14 minutes, penconazole at 15 minutes, hexaconazole at 16 minutes, propiconazole at 19, 19:28 and 21:93 minutes, and epoxiconazole at 21 minutes. For solvent selection by using PLE method, Sante 2017 state that the acceptable recoveries were within 70% to 120%. 2 compounds in 100% acetonitrile, 3 compounds in 1% formic acid in acetonitrile, and 1 compound in 1% distilled water in acetonitrile are the only had satisfactory mean recoveries range from 74% to 110%. On the other hand, for solvent selection using catches method, acetonitrile, 1% acetic acid in acetonitrile, and 1% formic acid in acetonitrile provide the acceptable recoveries, which are in range 77% to 84%, and standard deviation is below than 10% for all the 5 pesticides.
In table 3, we can see the vortex time on 5 minutes by using 1% acetic acid in acetonitrile was selected due to achieve the acceptable recovery in 73% to 88%. Vortex time of 10 minutes by using acetonitrile. It is also in acceptable recovery range, which is 76% to 93%. However, from an industrial perspective, the increase in extraction time is not preferable and more time consuming.
For the SPE cleanup by using PLE method, no interfering compound also were detected. Fluorescein removed the co-extractive of the final extracted of mesocarp effectively. By looking at figure 5, we can see fluorescein reduced the background noise more than the other sorbents. Graphitized carbon black GCB plays the role for removal of the pigment. As we can see in figure 6, before and after cleanup by using GCB show of reducing yellow pigment of mesocarp extraction solution. For the SPE cleanup using catches method had been used 50 mg of PSA, 50 mg C-actin and 150 mg magnesium sulfate. Based on the figure 7, the magnesium sulfate, PSA and C-actin show the decreasing of peak of chromatogram and reduced background noise for CPKO sample. In conclusion of this project, catches method provide a fast and minimal approach for extracting the pesticide while achieving the acceptable recovery. PLE can be proceed with manipulate the static time and extraction temperature. For these two methods, it is need to further validate with repeatability at 3 levels, 1 ppm, 0.1 ppm and 0.01 ppm. And it is also could conduct the experiment with different operator. The challenge during my internship at MPOB lab has many unfamiliar and high technology equipment that the student has never experienced before. It became a challenge to understand better on how each equipment works and what the analysis will do with the equipment. Thus, the students better to do the revision about how the equipment works and always ask the supervisor or staff for better understanding. A mistake could be show the unfavorable result and need to redo it from the beginner again. All the procedure of project must be carefully followed by the students, and every single step must be done properly to obtain the best outcomes. The worst scenario was when the government announced the Movement Control Order (MCO), which started on 1st of June 2021. The validation method did not do it, as COVID-19 issue that prolonged until the end of internship session. The student advised to do preparation before MCO outcomes and have a well-organized schedule. Skills and knowledge that acquired from internship program is capability to improve my lab skill that already had learned in university and apply to industry. Able to work with a group of people for achieving a shared goal and outcome in an effective way. Able to think the problem solving in variety ways to achieve the best possible solution, and being able to adapt with the environment and working culture.
This is my lab workplace. This is the reference that I had used for this project and my report.